With the PyPy guys, we're going to have the last talk of this session. And this is going to be making Jython faster and better with Jim Baker. Jim is over at Canonical working on Ubuntu Server. A lot of you probably use that product. And then his part-time works on Jython. So, Jim Baker.
Thanks. So this is actually a collaboration. In general, we have a large community, but especially the results I'm going to speak of in terms of working on Invoke Dynamic and some other applications of that. This is a collaboration in large part with some people at the University of Colorado. I happen to live just outside Boulder, so this is a very convenient physical proximity. And one of them, Shashank, I'm sure he's here right now. Shashank? Are you here? Oh, so Shashank has worked with me extensively on this, and so I'll be presenting some of his work here. Okay. So I'm going to go and discuss the status of Jython because we really need to tell you how that is going because, you know, we periodically disappear for a while because we're employed doing something else, but there is some work that's going on right now to go and bring back full-time development on Jython. And also some of the performance opportunities, which is really what I'm speaking about today. But first, I always have to plug this book that I co-wrote. If you have any questions about Jython, please, you can either order it online at Amazon.com or just read it for free, jythonbook.com, or get the RST and translate it to another language. I don't know. Just, it's out there. Please use this resource. So we just released the beta 1 of 2.5.3. We're just fixing some Windows issues, nothing really major there. It's going to be done by the sprints for sure. Currently our performance is roughly comparable to CPython. I can give you some bad cases where that's not the situation, but in general it's pretty comparable. And it's nice. I hear, you know, there's certainly a lot of production usage out there. I think maybe a lot of people in this room actually do use Jython, and certainly have, you know, many more people here at the conference have used it in integrating with Java. What's interesting about that is that there's continuing new usage as well, like tools like Sickly come to mind, which is a tool for going and testing visual applications, GUI applications. Things like that. And we have just started work on 2.7. So Frank Wierzbicki recently was hired to go and get 2.7 out. And he reported to me yesterday that after 2 days of work, he's already fixed the grammar. So we're ready to go and move on to the next step of 2.7. Seriously, there's nothing like sustained full-time work on any project if you have that luxury. We're going to be updating the runtime. 2.5 to 2.7 has some upgrades in the standard library. Some of the nice things about that is that there's a lot more unit testing for those changes than there were previously, which makes it a lot easier for us to go and actually find out what we need to fix. And then there's some minor breaking API changes, which not really terribly interesting here, but if you are using these APIs, be aware. If you are using them, I think you'll know how to fix them. So I saw that Jonathan Ellis is presenting what Python could learn from Java later today. And so I thought it would be nice to say what Jython has already learned from Java. Because pretty much all the points that he brings up, we've already covered. We use threads, we have no-GIL. That's a very nice aspect of working with Jython. We do have the best concurrency support of the implementations out there, though STM support will hopefully change that for PyPy. We'll see. You can use Java in I/O. The low-level support of using Java util concurrent is great. You can use executors and futures and work with new Java 7 functionality in terms of fork join. You got garbage collection. There's no reference counting. You can use JMX not just for your underlying VM or app server, but also for your own applications. Is it more functional than CPython? Well, we do take advantage of some of the functionality that Jonathan quotes, like the Guava stuff. And lastly, I wanted to cover every one of his points. So he mentioned immutables. This is, of course, not part of Python, but you could go and make them if you wanted and change the Python dialect as some sort of user pragma. And I'll talk a little bit about how that can be done. So the real discussion today is about the future of Indy Jython, which is what's going to come after 2.7. And this is taking advantage of new functionality in Java 7 called Invoke Dynamic as a collection of such functionality. What are the steps to going and actually making Jython faster? Well, if you were in the previous discussion about PyPy, there was some, if you think about what Python is, you know that it's a dynamic language. Of course it's a dynamic language. What does that really mean in terms of how that actually is actually run on some sort of virtual machine? And I'm going to be describing that. But we can go and actually work to make that faster. And there's also, despite the fact that there's a dynamic language, if you make certain assumptions, which I will hopefully convince you are quite reasonable to do, you can actually go and do some static analysis that goes beyond what you otherwise could do. And this is going to rely on a pairing of optimization and de-optimization as supported by the JVM itself. So one of the things I like to tell people is rewrite Java so you don't have to. But this moment, I'm asking you to think of yourself as if you were writing Java code from some Python code. I mean, this is a terrible idea. Don't do this. Let us do it, unless you're going to help on Jython. We really want you to go, right now there might be situations where you needed to optimize a small percentage of your code, but in general, you don't want to be doing what I'm about to ask you to do. And so the question you would have is, I need to rewrite this code to Java. What would I do? And so some of the things you would need to know is, of course, what are the semantics of Python versus Java? How they blend in terms of, like, for instance, Jython can subclass Java classes with Python code, that sort of thing. And most importantly, what is the actual intent of the code? Now, you get to have the intent of the code because you are a person who can look at this, and there's probably some documentation, and maybe you even trust that documentation. Obviously, if we're writing the compiler, we don't know the code's intent, but we can discern some of that by seeing how it actually performs in terms of its runtime. So we wouldn't have compiler stuff if we didn't show really trivial examples. This is not the place to find out about complex APIs for actually compiling them. So I'm going to use Py. All right. So I'm going to import math, and I'm going to print math.py, and really it's about that simple. And if we were looking at that, we say, well, why is it that this is what's going to result? And of course, the reason you see this resulting code, which is disassembled from the produced Java bytecode by Jython, is it has to go and always, when you said math.py, every time you access it, it's going to look up that, it's going to do a get global on the math module to find this attribute. It's going to look up the math as a global and get an attribute pi. And then there's going to be some other stuff that's being set up in terms of, what are our frame support, things like that. But there's a lot of extra code that's going on when all we really intended to do was this, right? This was your mental model. You as a Java/Python programmer given this task. And what we're working on with Jython is allowing you to actually let the Jython compiler produce this code for you. And still allow for all the dynamic functionality to take place. So that's the trick. So the JVM does a lot of things well for you, and it actually does a lot of things well for us right now. Otherwise, we would not be seeing the comparable level of performance with CPython right now. But it's clearly not good enough because we're not comparable to what PyPy is doing right now. And this is unfair because we should be able to take advantage of what the JVM engineering has done. PyPy's had to build all this stuff by themselves and it's been a lot of time. We should be able to be lazy and allow the JDK developers to go and do that for us, and that's our intent. Well, actually, we have to do a little bit of work to do that. And even I wish it were something we could just go and, like what Paul Graham was saying, you could just let someone else do it for you. But I guess it's us that has to do it. And so some of the nice things that the JVM does is it actually is very good about optimizing a certain set of code that I would call common or good idiomatic Java code. You know, the sort of stuff that's written day to day by a million Java programmers. And even some of the bad stuff, it also does a reasonable job of. What it doesn't really compile well is stuff like that. So we need to make it look more like this if we're going to succeed with this project. And it can go and do a lot of common things, which was also discussed in the PyPy talk. One nice thing is that it has this fantastic inlining capability, where it can not only inline this chunk of code, but it can inline with respect to the chunk of code that code called, and so on and so forth, up to a certain level. I believe it's about 9. It's heuristic as most such JITs are, but it's pretty impressive, and it actually, again, can work on some Python code executed against Jython. And that's why I'm saying inlining is transitive, and that's always a very powerful capability. There were some optimizations that were discussed earlier in Benjamin's talk. Those optimizations are a bad idea for running on a JVM. JVM is not something that runs your JIT on top of its JIT. Only one can run here, okay? So don't do SSA. This was tried with JRuby a while back, didn't work. Even if you fold a constant, it doesn't really help. Might actually produce worse results. Write good Java code, or in our case, it's bytecode equivalent. So we're going to go and exploit these capabilities, but we have to adhere to Python semantics. And the most important thing is we're going to try to cheat as much as possible. Cheating is a good thing. Cheating is exactly what was being discussed by Alex Martelli yesterday in terms of easier to ask forgiveness than permission. Okay? Of course, we usually call that de-optimization. So optimization is something along these lines. If we can prove that X and Y result in equivalent outcomes, then if Y costs less, we can freely substitute. And so the example I would quote is, you're asking what is the ultimate answer to the ultimate question of life, the universe, and everything. And you could have this computational program that takes 7.5 million years, or you could just say, it's 42. I'll just put 42 in there. De-optimization is something that you would have loved to have in your math classes, all right? If you have a bad proof, a bad set of assumptions, you can, if the JVM or your virtual machine supports this in its JIT, if you can go and at the point your assumptions are proven to be bad or wrong, you can say, oh, no, I didn't mean that. Let me back this up. Let's see where we go from there. That's what de-optimization allows, and what we have to do in order to support that is guard our assumptions. So the Invoke Dynamic Toolkit is basically something that was exposed from Java, the JVM's internals, out to programmers who want to use it at the Java level. So you don't have to modify Hotspot to make these optimizations. So we're able to go and take advantage of what it's already doing internally in order to go and better compile Java code, to give it some guidance on how it can better compile, say, Jython, or a Python code, I should say. And some of the key features of that would be the Invoke Dynamic Bytecode, which allows you to actually take some metadata and link it to a call site. And then, of course, the call site, method handle, and switch point, which are the objects that you operate on when you're working with these capabilities. And it's part of Java 7, which was released last year. So how do you actually use Invoke Dynamic? You basically need to go and emit an Invoke Dynamic bytecode, give it the name of your Bootstrap method, and any other metadata or access to constants in a constant pool that you want. It's extraordinarily general what you can do with that. I mean, it's very nice. And that Bootstrap method, which is invoked the first time that is run, when that code is actually run, is to replace it with a call site, which is linked to a method handle. And that method handle then is this little code thunk, or chunk, I guess, which can be generated in any number of ways. And probably the most useful way is to use this switch point guard with test. And this is the essence of what we use. So a switch point is this thing, let me make sure, yeah, I'm not covering it just yet. A switch point is something that I can it's an efficient way to construct a guard from a distance. If I know in my runtime that something has changed, I can throw that switch point, and now instead of executing the normal method handle, I execute the fallback method handle. And what happens at that point is that anything that actually was using the normal method handle is popped out of what's being executed. There's everything that needed, any of the assumptions that were made are unmade. This is pretty powerful. Some other things that you can use to build method handles, you can build method handles that permute arguments. I'll talk about that in just a moment, what that means. You can have a method handle that returns a constant, like my math.py. You can bind an object to a method handle, and that is essentially what is bound method support. So we want to have efficient guards when we're writing this stuff, and switch points are pretty important for that. They have this action at distance quality, which is great because that's what we're seeing with dynamic languages. So for instance, let us say that there is some legislator out there that is persuaded that pi is equal to 3.2, and they introduced this bill to change it in your global namespace. That's action at a distance. Someone has, and is this something that should be done? It's Python. We allow this sort of thing. It has these volatile memory semantics, but they're converging on making it zero costs, and without even the volatile costs. Switch points can depend effectively on other switch points. It's the key to de-optimization. I'm going to skip this because, all right. We have Git Global, which we earlier saw. This is how we would build something like this. Unfortunately, there's a little bit more involved in terms of actually getting this to work, in terms with frames and all these things, but effectively this is what we need to do. That's pretty straightforward, and it allows us to go and ensure that we know what X is, and if X was changed, there's an opportunity to reinstall that call site so that we can actually go and get the right value of X at that point. I want to mention this, some of the funky aspects of Python semantics. I don't know how many people are familiar that you can do something like this, and it's even arguable that it's even truly permissible, but it's readily supportable too. We just don't have to go and actually make it efficient if you were to do something crazy like this. So the solution here is to count all the exec contexts that are currently in effect with the assumption that you're using some func code that not from compile, but instead from some function in some random global namespace. If that is greater than 0, you are in debug mode. You get slow code for the entire Python interpreter. Everything running in that Jython bit is slowed down. Is that a fair thing for us to do? I think so. If you don't think it's fair, come talk with me. Probably will say no. But, if you can fix it, then that's fine. Something that's kind of cool is that there's opportunities for static analysis. So there was some discussion earlier in terms of in PyPy about its tracing JIT and so forth. And Hotspot is not a tracing JIT, and regardless, we couldn't build a tracing JIT on top of it if we wanted to, because that's just a recipe for spending a lot of time not actually getting anything more with greater performance. And I mean, seriously, that's not what we want to do. So instead, what we can do is something like this. I mean, again, think about you as compiler again. How would you translate this chunk of code? You're going to say, for I in X range 1 million, this is the normal Java snippet equivalent. And there's some interesting opportunities for type specialization. So if if it's X range, for instance, that always produces integers, so you don't have to box it, and so on and so forth. But of course, as we discussed earlier, X range can be rebound at any time. Someone could get into my global namespace, or I could have imported an X range that says, give me date times. That's going to break a lot of code, especially if you put it into the built-in namespace, but it's possible to do. So we don't prevent that. We don't prevent any craziness. We simply just go and guard that with Indy. And what is nice is we can use continuations to go and do this. It's similar to the black hole interpreter that was discussed earlier. So we basically can go and produce this nice optimized code, but if X range is changed, and actually I just realized that this is an older slide here, this would actually come from a switch point, same difference. Just we wouldn't have that guarded X range call there. And when you actually, what that really meant was there's an Indy call to look at X range. Yeah, I'm sorry, that would be the correct code. And that would be returning a constant like true or something like that. It wouldn't do anything in the normal case. But in the fallback case, it would actually go and throw this optimization exception. This optimization exception would basically put it into a state that would be recoverable in some sort of continuation. The only problem, and you can look at this later online, we have some work at gradual.colorado.edu, is JVM does not allow for arbitrary computed gotos. I don't know why. Why not? They actually do support goto, but if you did that for every single corresponding statement in your code, that would be truly expensive. Well, we can just go to our Python bytecode virtual machine that we've written on Java. It's always useful to have an interpreter. I execute standard Python bytecode, the 2.5 dialect right now, and allows us to take a frame and start it at any point in that corresponding bytecode. So now we have our de-optimized thing. So you changed X range, and now to return date times or maybe to go and instrument it in some way. We don't know your intents. If you had some noble intent, maybe we could work with that. If you had bad intent, of course, we will ignore that. But regardless, we're able to be in this interpreter to go and still execute Python code, no matter how crazy, in this dynamic context. And I actually wanted to bring this up because, but you'll have to look at this later. There are some reasons, again, why running on JVM is different than, say, PyPy. So this sort of static analysis is kind of nice. It works in general with iterators of various kinds, like generator expressions. You can't support generators with yield statements, obviously, because you the iterator expression must be contained, although Java 8 might introduce coroutine support, in which case this could be done. And in general, if we had that Java 8 support, greenlit and stack lists and all sorts of good things that would be also available. Currently, there's some experimental support that JRuby uses just for that. We can also be better about how we compile our code. I mean, we just haven't really done as much as we would like on that. And that's principally because writing an alternative implementation is sort of hard because you have all these fiddly bits that you have to take into account. Here's some of the things that we've actually worked on the calling convention, and I have some ongoing work to improve generators. And I'm going to skip that. Okay, so I had some ideas in terms, we're going to have a sprint on Jython this week. I'm actually going to be here through Thursday. And there's some discussion earlier, how easy is it to hack on these alternate implementations? Well, I will say that it's easier than CPython for Jython for sure. Is it easier than PyPy? I don't know. From my perspective it is, but it's certainly the sort of discussion that is best done over beer. So what if you were to actually participate in the sprints, and I don't know how many people here are actually planning to attend the sprints? Okay, so I can be evangelical right now. Hey, there's a lot of easy 2.7 bugs to fix. I remember when we were going to 2.5, and we were making this huge convergence on getting 2.5 support. And truly, it was that long tail in effect. Is that we were at the easy part of the long tail, where all those easy, juicy problems are there, and you can fix them like 5 modules in a day, that sort of thing. So that would be great. I mean, if you wanted to go and work on helping with that, especially like the standard library support or other aspects of the runtime, I think you would actually find that to be pretty straightforward. There's this fun stuff in Invoke Dynamic. I'd love to talk with people about that. One thing that I didn't really get into, because we still are thinking about these issues, is how static analysis could actually improve Java integration support. There was this functionality called Jython C that was available in the past, and we should be able to do something similar utilizing a combination of decorators, Java annotations, and so on and so forth to get at a better level of Java integration. I would like to hear your ideas as far as that is concerned. I think that user input is the best way. I have a certain set of things I might be doing, the other members of the Jython team might be doing, but you have much more insight into how you might use Jython in Java integration in general. And lastly, I was asked earlier about Android this morning at the PyCon 5K run, and I would just say, please ask me about Android. I have some ideas for that support if you're interested. When there was a G1 phone, this really didn't make that much sense. When you have great tablets out there, being able to go and have that support on Jython support to be able to interact with the Android ecosystem might be very compelling indeed. Okay, any questions?
I got one for you, Jim.
Mm-hmm.
First of all, I really appreciate what you guys are working on. Mm-hmm. You know, kind of thankless sometimes, but it's awesome stuff. I was wondering, just thinking about what you're saying about programmers signaling their intent, and you know, if you know ahead of time what they really want,
right,
you can kind of target that better. And just looking at the efforts of the PyPy folks and what they've been able to accomplish through the use of decorators. Is that something you guys have looked at doing, using, allowing Jython programmers to use decorators to indicate their intent so you can optimize
Absolutely,
them?
absolutely. So, you know, a good example of a decorator that could signal intent, and it's something that, you know, you could even say, I know about someone else's code as well, but let's say I'm just doing it through a decorator, is frameless. If I know that this code doesn't, I don't need to access the frame. And if I were going and actually had something that was implemented in the, say, the CPython runtime, you can't get its frame. There's no frame for you to access. And certainly that's also the case with Java code. So it's not necessarily the case that in a lot of code you should be able to access that frame, see what its locals are. It's a great way to debug, but debugging is a separate thing altogether as well. We can support the debugging case. So if we know if you really didn't want to have this used with frames, then that saves a lot. And I don't know what the, when all these things are kind of put together, because these are sort of non-linear effects in terms of how they multiply out, but you know, you could easily see in certain types of functions 5 to 10 times improvement for the overhead of something like that, removing the need for the frame.
I haven't been in the Python community for very long, but one thing that's obvious to me already is that it has a very heavy dose of religion. How much do you think that religion is responsible for the unpopularity of Jython? And how do you think people justify it, or how do you think Jython should defeat it, especially given the number of problems that Python is trying to solve that other languages solved a long time ago?
Okay, well, I actually think that from a, since I'm in part a Jython evangelist, I could answer religious questions. So, you know, Jython has currently a very good use case in terms of integrating with Java code, and I think that's why people use it. It's very appropriate, and if you, and it's and the secondary thing that people find is that if you're running, say, Django on Jython, you can deploy your production Django app as a WAR file on a standard app server, and it just works in a lot of cases. If sans don't use CPython extensions, things which wouldn't even work in general on Java because of general security managers restrictions that you would see on most app servers. But in general, I think we have to go and prove something that's compelling. Better performance, better access to concurrency. If we do that, then people will be interested. I was in the same PyPy talks 3 or 4 or 5 years ago, and it was just like this in terms of the numbers, and we were in the PyPy talk just an hour ago, and it was standing room only. So I may be speaking to people who see this future, realize that the JVM is really good at running certain types of workloads and in certain environments that Python currently doesn't access. Maybe the concurrency stuff is something that PyPy will address in a very interesting way with STM, but there is still a lot of, the Java ecosystem is here to stay, and Jython is a great response to that. I mean, again, we write Java, so you don't have to. I'm sorry, I just wanted to continue one more line of thought here. And the last thing is that I've actually had the chance to interact with other alternative implementations for other languages on the JVM. And the reality is that Jython is actually really first class at the table in terms of in the Python development community and frameworks and whatnot. So the users will come when we have something that's completely compelling if they don't need that right now. And if they need something but they don't have the 2.7 support, well, we're going to be delivering that. Well, that's pretty good. And we're going to be delivering it because we're working very, the work that we have done with the PyPy people, for example, to ensure that there are pure Python versions of libraries is just going to make that much easier. The fact that there is good testing is going to make it much easier. We don't have this sort of non-transparent scenario where we don't even know what the implementation is supposed to do, which you might find in some other implementations. So I really think that there are no religious issues dividing us here. There's simply practicality.
So the question, just to emphasize the point, was do you think Jython, the cases that you mentioned where one would go and deploy Jython were all special cases where you have to deploy a WAR archive if you're living in a J2EE environment. Do you think that for the general case, Jython does not yet have a compelling reason to switch to it?
it's fine. I mean, I can understand why people want to go and use, some nice library out there that is using C extensions. I mean, we have lots of users. There are 200,000 downloads of Sickly, this new project that uses Jython. That's enough users for me. I don't know. Maybe only 10% of them actually used it, but it's used in a lot of different places. And I could name other projects that are interesting like that. Maybe not as cool as Sickly, but definitely pretty widely used.
I mean, the interesting observation to me as somebody who's come into Python from other older programming languages is that the threading, concurrency, and sheer throughput is not considered an essential for a Python application.
Yeah, that's a great question. I mean, you can, so I think part of that right now is that to really take advantage of that functionality in Jython, there is a bit of having to occasionally dip down into Java in order to make that really work well. And so that can throw people off. But it's there, and it's not necessarily, it's going to be your 5% of your code. And let me tell you here that, of course, what we're doing on this optimization stuff is exactly covering that 5% of the code that takes 95% or 99% or whatever it is in terms of that Pareto analysis and makes it run faster. We do want to cover that because that is going to make it a lot more competitive. Hope that answers your question. Any other questions here? And I'm quite willing to go and talk with people afterwards. Okay, thanks. And please come for the sprints. I'm going to be here through Thursday. And also, we have a Birds of a Feather session at 7 p.m. Tonight.